Hello and welcome to another episode of the Feudal Future podcast. I'm Marshall Toplansky.
I'm Joel Kotkin.
And today we are delighted to have with us two experts in the area of space and the implications on both communication, national security, and the potential for space being a new source of energy for us. I'd like to welcome Rand Simberg. Rand, welcome. Rand is a longtime aerospace engineer, having worked at Aerospace Corporation and Rockwell International. And Ashwin Rangan is CIO of ICANN, which is the group that basically we all work for, right? Right, Ash? They control the internet naming services. So anytime you enter in a URL, ICANN is in charge of it. Ashwin is former CIO of Wal-Mart and former CIO of Rockwell Semiconductor. Gentlemen, welcome.
Thank you.
Good to be here.
Glad to be here too.
Great. Well, let's kick it off a little bit. I want to look at space as a potential area of opportunity for changing the game for us mere mortals here on Earth. Rand, you've written a lot about space medicine, about space as a potential area of electrical generation and wireless electricity transmission. What's your feeling about the future of that? Is it close in? Is it unrealistic? Is it just fantasy?
Well, it's been a concept for decades. It was invented back in the 60s by Dr. Peter Glaser at Arthur D. Little. But the problem with doing anything like that in space has been the cost of getting into space for decades. Fortunately, not much thanks to NASA and Congress, but thanks to visionaries like Elon Musk, we're solving that problem.
So the cost of actually getting stuff up there used to be a gigantic fixed cost, and now with reusable rockets, we're talking about bringing the cost down dramatically.
Yes, and we're going to be having true reusability. The shuttle, people drew a lot of false lessons from the shuttle, and one of them was that reusability doesn't reduce costs, which was just nonsense because it was such a, that's the fallacy of hasty overgeneralization. You take one example and say, "Oh, crews can't do it," because NASA always sort of takes a Wile E. Coyote approach to things. They try something, it doesn't work, and then they give it up completely and they go try something else.
And it sounds as though there may be a good deal of a bureaucratic stick in the mudness there as well.
And there's a great deal of risk aversion and a government space program it was a good idea to try to have the government run a space line.
Yeah, and I actually want to get back to that a little bit because I know you've written extensively about our obsession with risk aversion and the need to make sure everybody gets back alive is tamping down our risk appetite for being able to explore new concepts in space. But before we get to that, Ash, I want to look at this whole notion of reusability. Has played to the advantage of Elon Musk in putting up the Starlink system. Yep. Tell us a little bit about how that Starlink system works and what the implications are for global data communication.
And I want to say particularly rural and developing countries, where the infrastructure is not that great.
Right.
Well, it's also worth noting that they just got permission to put them on, they're not fixed ground stations anymore. That means we're going to have probably much better internet on airplanes. You're going to have it on cruise ships. You're going to have it on, be able to track ships. What few crew are we to that?
How close are we to that now, Ashwin?
We are getting closer and closer. Real-time tracking. Well, first of all, I think it's important to step back and then we can lean into this. I date myself probably by about 6 months with the data points that I have because tracking and reporting on these tends to lag reality itself. So the last reports that I read around Christmas time, I don't recall whether it was in January or February, is when I got to read them in some detail. there were roughly 4,800 satellites that were attributable with ownership in space that were publicly disclosed. That's not to suggest that that's the total inventory, because there are numerous satellites whose identity is unknown and there are no claims on identification at all for reasons that you can surmise. So of the 4,800 at that time, roughly 30 to 35% were owned and operated by SpaceX Starlink. So their entry was with a big splash. The focus, when you think about it, was on the reusability of their rocket. But the real story was with the nature of the satellites that they were launching. So I think it's also helpful to understand that from a historic perspective. You think back 30 years, and I'm sure Rand will corroborate this, the number of countries that had the ability to launch a space vehicle was dramatically small. That number has been increasing. So for instance, when India launched its first satellite, and I recall this being in engineering school at the time, they had to rely upon the Ariane rocket from France to take the satellite to space. That's no longer the case. India has its own capabilities, and so do a number of other countries. So the rocketry science, which used to be previously guarded as a national secret, has slowly but surely expanded its orbit, pardon the pun, so that more and more countries now have that capability. So that's one factor. The second factor is the satellite itself. When we used to think of satellites 30 years ago, the mental conception of the satellite was something the size of a bus.
Yeah, like Telstar or something like that.
Yeah, it was an enormous piece of equipment that had to be launched at incredible cost because the volume was big and the weight was high. And those are the factors that contribute to the cost of the rocket that needs to take it up. Now compare that with a SpaceX launch or one of the more recent launches from the Indian Space Research Organization, ISRO, where a single launch resulted in the deployment of 100 satellites. These satellites today are roughly the size of half a shoebox, with the same sophistication that bus-sized equipment used to have 30 years ago because of miniaturization in technologies and software capabilities. And their capabilities today are multifunctional. They could be multi-purposed, but they typically tend to get deployed with a single purpose in mind. So when you look at that 4,700, 800 number that I recall from around the turn of the year, about 60% of them were dedicated to communication. The other 40% were special purpose. About 20%, if my memory serves, were geo-observation satellites for weather and other reasons.
And old-fashioned spying.
That too.
Well, let's just talk about the communication element of this for a moment. Are we talking about high bandwidth communication that can handle video and, are people going to be, are our next generation of astronauts going to be able to stream high definition pornography from their space?
You had to get there sooner rather than later, didn't you?
Not the ones that are NASA employees.
What is the nature of the communication? Is it full spectrum, high bandwidth kinds of things, or is it different?
So if you think about it, there are two questions hidden in there, right? One is the full spectrum, the other is high bandwidth. So let's talk about both. When you think about satellites, there is an inherent factor that has to always be considered, and that is, in what orbit is it? Is it in geosynchronous orbit? Is it geostationary orbit? Is it low Earth orbit, high orbit? I mean, there's a number of different places. There's this place called, I think if my memory serves me right, called the Lagrangian space point, where you can put a satellite, it's in perfect harmony between the sun and the Earth, for instance. And that could be used for things like a telescope that's reaching out to the farthest edges of space. There's a different orbital points that are used, right? But no matter where it is, there is a fundamental physical time distance equation that doesn't resolve in something that can be highly responsive, because there is that time delay factor depending on the distance, which is different from earthbound infrastructure where you can literally light up a fiber optics circuit and it travels at the speed of light. Here, there is this physical bounce that needs to occur between the Earth and the satellite and back again. So it's not so much about how much bandwidth can we provision, it's about the jitter that comes with it and the delay that comes with it.
Yeah, so
That's one of the reasons that Elon did Starlink was that he wanted to have low latency. That's why they're low altitude satellites. You get to geo, it's a significant fraction of a second to get there and back.
Yeah. So now we've got that, right? We've got 36% or whatever you said, the number of satellites percentage of satellites that are Starlinks out there. What does that do for humanity? I mean, what kind of communication does it engender or enable? Where can you communicate? What has it done for the world?
So that's an excellent question. You know, the initial impetus when SpaceX and Starlink started to go up was to provide coverage where there was no prior coverage. You think about the surface of the Earth, and most of the ocean spaces were not covered at all. And therefore, you lost connectivity the moment you were in an airplane and it hit international sort of borders. There was no coverage. Rand briefly touched on the fact that these will now be enabled through licensing agreement and other means to have that connectivity. You know, Boeing tried this 10, 15 years ago, right? They tried to figure out how to make these satellites communicate with their planes while the planes were in the air, no matter where. But it didn't quite pan out for a number of reasons, regulatory being one of them, technological being another. So with SpaceX and Starlink, they're overcoming certainly the technological with ease, relatively speaking, and more so the regulatory, because the benefits are starting to far outweigh the cost, given the low cost points. So you are seeing more of that. From a communication perspective, think about it this way. Fundamental communication in sub-Saharan Africa, if you think of that contiguous region as just one region, I mean, it's a vast swath of land that's 23 countries, actually. But if you think of that vast region, infrastructure there has lagged because of investments for many decades. But in the last 10 years, fiber optics has connected that space, but around the southern half of Africa. What is not available is fiber optics into the interiors. So when you have signal to the edges and it's not able to get to the interior, you need to find some way of making that happen. 5G has the promise, but that says that you've got terrestrial stations along the way carrying the signal around. They don't have the wherewithal for that. So Starlink started to focus on those areas that were underserved, like sub-Saharan Africa. And through that, started to open up two different things from my perspective. One is basic communication capabilities, and the second is enabling African innovation like M-Pesa for borderless financial transactions using short messaging and cellular telephony. So this connection, the low latency, or high latency, I should say here, did not matter because these were short messages and they were going across all kinds of boundaries and enabling new things to happen. So it started to prove the case in spades that this was not only viable, but that it was extremely scalable. So now we are starting to see the benefit of that, and so is SpaceX, because their promise to the world is we're going to launch 1,000 of these every year. And if you can deploy 100 of them with each launch, that's not a goal that cannot be achieved. In fact, it's well within their reach now.
It's also worth noting that thanks to Elon specifically, Ukraine has maintained internet through the war.
Totally.
Yeah, now let me just ask a question about that, because I'm hearing something that is a little different than what I had thought all of this was about. When I think of internet coming through space, through satellites, you know, my mind goes toward relatively high bandwidth things like, watching a YouTube video or something like that. What I'm hearing is that, no, that's really not what this is about, that we're talking about much, much more primitive and lower data transmission rates. Is that right? Or is it full up, like multi-megabit kind of data rates?
No, Starlink is high bandwidth. I mean, one of the goals, that's one of the reasons that Elon wanted to get rid of the latency issues that you have when you go to geo and back, is he says you should be able to game with this.
Agreed. By the way, I'm speaking to you with a Viasat Starlink right now, or satellite link right now.
Oh, you're kidding.
Yeah.
And how did you do that?
Well, I have Viasat in my home as a backup to my land-based system because I can't afford to not have connectivity at any time. So given the topic at hand, I thought it would be interesting and appropriate.
Oh, that's very cool. So it's not just short message, 5K kind of bits per second. We're talking about full up internet.
Yep.
That now you, Ashwin, you in your job at ICANN, you have to work with over 100 countries.
Yes.
To be able to manage the internet, in essence, manage the flow of traffic and what the dynamic name servers are all about. Are you finding any pushback on all of this, on this trend? Or, I mean, how are people around the world, are they embracing this or not?
So it may be worth a while talking a little bit about ICANN so that we can clarify the messaging here. It would certainly be helpful for me to clarify it for you and the others who may be listening to the podcast. So ICANN, as you started out by saying, we are accountable to the world for top-level domain names like .com, .net, .info, and many others. There's like 1,200 of them. And
.space.
Yeah, .space. And country-level TLDs like, .za for South Africa and .ru for Russia, things of that nature. We are also responsible for the management of IP addresses and allocations around the world. And finally, we're responsible for the protocols that make these work in a secure, scalable, and resilient manner. And a lot of the engineering that my team and I do is on that backplane of resiliency, where we provide what are known as recursive resolvers. So when you say Marshall at Toplansky.com, the .com has to point you to some server somewhere or some set of servers somewhere, which in turn has to point to Toplansky as a specific server, which in turn has to resolve and say, who's Marshall? And is he a legit member of this Toplansky group? So there's multiple levels at which this has to resolve and come back to you with information from one computer to another. And we do this by scaling the backplane so that you get sub-microsecond response times. Literally 2-3 microseconds is about the level of tolerance today. And I just want to pause there because you think back 20 years, you were quite happy with Finger or Waze or one of those early search engines to fire something off, get a cup of coffee, come back and see something in response. Where today, if you so much as blink an eyelid and something is not back at you, you move on to the next website. So there's this attention span disorder that's crept into our collective consciousness here, right? So we continuously run ahead of that, trying to make sure that that is not a reality and that you enjoy that fast response time. So when we're doing that, there is the physicality of what we do, and then there is the logical layer, which is the software layer where you're seeing over-the-top services. So this, what we are using, Zoom, is an over-the-top service. I mean, they're not at the infrastructure layer. They're taking the infrastructure for granted and making their service available on that infrastructure. So when you think of SpaceX and Starlink, what they're doing is to make the physical layer happen. And what the over-the-top players are doing is to take that physical layer for granted, and they're just riding on it. Mm-hmm. And part of the discussion in the broader ecosystem of technology today is because the over-the-top guys are riding for free, the physical layers guys are like, look, we incur all of the capital expenditure, and you guys just take us for granted. We get shafted.
Right. We have to pay for fixing the leaky toilet, right?
Yeah, it's amazing, how something that would have been considered a miracle has somehow become an entitlement.
Yeah, exactly.
Yeah. Joel, you had a question you wanted to pose in here.
I was wondering now, if I'm reading this right, we're moving to a world where accessibility to the internet is universal pretty much everywhere. Does that change the geopolitics of the country? Since many of these countries, let's say in Africa, are run by not very nice people who maybe now have greater capacities. I mean, no offense, but I find sometimes tech people don't think about what the possible negative results might be.
It's a double-edged sword because, on the one hand, it makes it a lot harder to prevent people from communicating, which is something that totalitarians like to do. But on the other hand, it also creates a big brother,
Right?
with the applications of it, with the big tech companies.
Yeah. So, and then the other question I have is maybe leading into it is the idea of surveillance. Is this going to make it much easier for the government of the Congo or the government of Uzbekistan to control their populations?
Yeah, or is it going to make it easier for Texas to track people going to California for abortions?
Right. Good point.
Yeah. I think that's exactly right. It's a double-edged sword, and I think it's a use case problem as opposed to a technology problem. That's always been the case with every technology, right? When fire was invented, it was good for cooking. You could burn people down.
Right. So there's always something. Joel, you're still muted. There's always some negative implication. One of the premises that Joel has in his book on the reemergence of feudalism is that the power to exercise bad outcomes as well as good outcomes is being concentrated in a smaller and smaller number of people. And I wonder whether just this is a natural consequence of this technology, that it becomes something that is wielded, a power that's wielded by a smaller number of people. What are you seeing in the world as far as that?
Well, let me take a swag at it, and then I'm really interested to hear Rand's viewpoints on this as well. There are two forces at work here, right? One is technology has a natural tendency to be democratized. We just talked about the fact that the price point of a satellite has been dramatically reduced over the last 30 years. Accessibility to the internet was a privilege, and now it's considered to be a fundamental human right. So that tells you how technology can, in fact, be beneficial on the one side. The use case of it on the other side is really where there could be darker overtones. Every technology has the potential to bring that darker overtone hand in hand with it. If the actor is malintentioned, then they can hijack the technology for the wrong purposes. So that's the way I look at it. Now, that said, if the players in the space have the ability to invest with a good use case in mind, the speed to volume has been reduced given the nature of these technologies, so that there is a mover advantage. May not be the first mover, could be a fast follower, but there is an advantage. And therefore, there is the opportunity for a quote unquote land grab. And we see that in instance after instance. But that doesn't mean that there isn't room for players 2, 3, 4, 5, because even the land grabbers don't have the ability to scale globally, and certainly not fast enough. So there could be regional players who have similar, if not identical capabilities, or even superior capabilities when viewed from a particular national angle. So
that's very much what we see with China. China now it's a sort of a parallel internet, right?
Exactly. So the experiential factors could vary, and there could be multiple regional players offering similar, if not identical, capabilities. And I think that's the nature of what we will see. So in the context of a region, you could make the claim that there is a polarization of value and capture by a certain individual or a small group of people, creating an oligopoly. But in the global context, it's really difficult to make that case.
You know, Jeff Bezos makes the point that he could create Amazon because he could build it on the infrastructure that was developing from the internet, and he wants to do the same thing with space. He says we need to build the infrastructure that's going to allow us to achieve all these things that he wants to achieve in space. And though right now Elon's doing a lot better job of that.
But it still is the opinions of a few movers and shakers, and the will, right, of a few people that are going to create these opportunities. Let me just ask you this question, Rand, in particular. So we've been talking a lot about building out the communications infrastructure of space to be able to link people together and create all of these applications that the infrastructure will serve. Lately, there's been a good deal of conversation about building out the energy infrastructure of space, being able to generate electricity through solar voltaic cells in space and then beaming that down wirelessly to Earth. Where do we stand on that?
Well, I guess we started out this way, and then we got into communications. We're a lot closer to it now than we've ever been because the cost of access is coming down. The solar power satellites didn't make sense in the 70s. They didn't make sense in the 80s. They didn't make because it just cost so much. It was it's $10,000 a pound or more to get stuff into orbit, and even more to get it out to geosynchronous orbit, which is where a lot of the concepts I think will be. Though there are some ideas now about, like Starlink, having lower altitude ones, which means you can have smaller antennas. You can have, but the problem with that is it's like GPS. You have to have the full constellation up in order to have 24/7, baseload electricity. If you, whereas a geo, you can have one satellite sitting out there looking at a place on Earth, and it's always coming in. But there's a lot of work going on, a lot of exciting things happening right now in the area. In fact, I was just at a conference in DC over Memorial Day weekend, and they had a one-day workshop basically on what's going on in space solar power. John Mankin.
Is this a private industry-led thing, the way the communication stuff is, or is this a government agency kind of thing?
It's a mix. I forget his name. Somebody just gave $100 million to Caltech to look into this. That was private funding.
That was me, by the way.
Your dreams.
You're welcome. You're welcome.
But the most interesting thing, and you really sometime talk to John Mankins about this, because he is Mr. Solar Power Satellite. And he held his workshop, and people were there from Japan, the people were there from UK, China is looking into it, and but particularly the UK is being very aggressive. They've actually put together a pretty big consortium, and they have some interesting concepts, and it's going to be a public-private partnership, I think. And John Mankins is very, he thinks like they've got like the most promising, not just technical concept, but business and how you put it all together.
Has the administration been at all? I mean, they seem to be obsessed with solar power and seem to be willing to drive the economy into the grave just to achieve these goals. This seems like a way of maybe making this more viable. Is the government have any interest in this?
Yes, and NASA is getting more interested. Traditionally, the problem with it has been, and back in the 70s, there were joint studies between Department of Energy and NASA on it, but NASA thought it was an energy program, and DOE thought it was a space program, and neither of them really wanted to embrace it. and the design reference concept they had was terrible. But again, it was a case of, well, we looked at it, it doesn't work, so.
Well, the thing that hits me about it in today's context is that it's as much of a communication issue as it is a generation question, right? How do you, in essence, moving electricity wirelessly from one place to another is a data communications problem, right? Isn't that?
Traditionally, the only way we've been able to make money in space, because it costs so much to get mass up there, and it costs even more to get mass back. The only thing we could to move value from space is via photons.
Or take massless things and move them, right?
Yeah. So we did that with ComSats, and now we're proposing to do it with actual power.
Yeah, and how does that work actually?
Yeah, because I was wondering what the advantages of doing it this way as opposed to how we're doing it terrestrially.
Well, the first thing, Joel, is there's no wires.
But the advantage of space for generating power is the sun shines 24/7, 365. Unless if you're in low Earth orbit, okay, you get eclipsed by the planet occasionally, but you'd always have enough up there. So the point is it can be base load. You can't do base load with solar on the planet because there's night and there's clouds, and but up there you can be generating continuously. So the challenge has always been, okay, can we get the efficiency, the transmission efficiency to the point where it makes economic sense? And back in the 70s, they were generating, basically you're transmitting. You can use lasers, but most people are saying microwave. But I think people get a little antsy about multi-megawatt lasers in space.
Ashwin, is this something that ICANN is at all gets involved in its world? Because it seems to me that you're still kind of moving data here, whether it's via microwave or laser or anything.
It's not data. It's just power.
Okay.
Yeah.
You could put a carrier on, or you could put a signal on it if you wanted, I guess.
That's right.
Isn't it a carrier wave that basically carries the electricity?
Yes.
That's right.
It's not modulated. It could be, but that's not part of the concept. It's basically you're just moving power electromagnetically.
But it's much more efficient economically if you can work out the details.
Yeah, but the point is now, if we get cost down to $20 a pound, there's a lot of things that make sense that don't make sense at $10,000 a pound in the world. Right. So it may be happening. I think there's going to be societal resistance. People are going to be scared of, remember they're worried about cell phones and giving you brain cancer. People are going to not be thrilled necessarily with the idea, even though it's very low power density. It's actually about 1/6 that of sunlight. But the reason it still makes sense is that even though it's low power density, it's a very efficient, much more efficient than solar cells on the ground using the direct antennas.
Well, and if all of this comes together in a kind of integrated system, it seems to me that you would end up having kind of a perpetual source of energy to run both Earth-based systems and all of the satellites that are up there, right? You could basically beam electricity around to all of the different satellites with or without, even if they didn't have their own solar photovoltaic cells on them.
Right, and you could also beam it to the moon.
Yeah.
And you could also build lasers, and you do them at a frequency that's opaque, the atmosphere is opaque to, so you don't have to worry about frying cities with them. But you could build lasers that you push light sails around with all over the solar system.
Mm-hmm. So these act as boosters for spaceships, basically.
Yeah.
Booster for anything, in fact, right? Because you think about it, there's this concept, you may have heard of this guy, his name was Freeman Dyson. Dyson came up with this concept of a Dyson sphere, right? Which is an enormous black body that surrounds the Earth itself or any celestial object. If you had a Dyson sphere essentially you would have perpetual energy forever, relatively speaking,
Hmm.
right?
Yeah, nothing's forever, but yeah. Well, a Dyson sphere, actually, the idea is you capture all of the energy of your star. It surrounds the entire solar system.
Yeah. So you think about it, what we're doing here with this massive flotilla of satellites is a very tiny Dyson sphere-like concept, right?
With just a little space in between, but that gets filled out, is what your point is, right? Well, and with all of the science fiction movies about asteroids hitting the Earth, maybe this would be a shield against that somehow. Who knows?
You've been watching too many science fiction movies.
Exactly.
Oh.
Well, gentlemen, this has been an absolutely fascinating conversation, and it sounds as though we have some reasons to be optimistic about the future of space, both from a communication perspective and from an energy perspective. Thank you so much for sharing your perspectives.
And I just want to add that I think it's a tremendous advantage, hopefully, for developing countries who have been killed by the pandemic and now the high oil prices. So to give that part of humanity, which is the vast majority of humanity, a chance to play in the 21st century economy, I think is a thrilling thing and something I'm really glad that you're working on.
Yeah,
That's
and
it.
if I could
And
add,
a double whammy because they've been killed by green energy too.
Right.
they are. And from a
So-called.
usage perspective, speaking to the internet component and communications here, one of the things that we're working on very assiduously is to create more language capability on the internet so that you don't have to be Latin scripted or English based, so that native languages and native scripts are recognized by the internet. And therefore, you can resolve the URL with your language on your keyboard without learning a new language just to interact with the internet. So those are advances that we feel will bring in more and more people from an inclusivity perspective. So take the many different things happening along with the language thrusts, and suddenly you've got access to the internet in natural formats increasing over the years to come.
Well, that's really interesting.
Well, in a world that is filled with division and divisive forces, it's nice to hear that there are some uniting forces.
And I think it's a question of how we handle it. Do we use this for good things or for bad things? And that's always the issue with technology. I teach a course on the history of the future at Chapman, and so we do a lot of science fiction. And there are some good examples, but really maybe this is part of a narrative of something very positive that should be laid out so people understand that there really is hope, and this technology is not just about making Bezos or Musk incredibly rich, but something that could actually transform the planet in a very positive way.
Well, gentlemen, thank you. We are delighted that you've been guests, and we look forward to having you on the show again. Thank you.
Thank you.
Lovely meeting everybody.
Great to be here.